All right, I wanted to derive this integral. When you derive an integral, and the integral, you have an interval from a constant to an x, and the interval is in a different variable like this, it's a second fundamental theorem of calculus. And instead of sitting there and integrating this and then going and deriving it, the answer is very quick and easy. All you do for the second fundamental theorem of calculus in this scenario when you're deriving this is you simply take the 5x and plug it in for t. And you take the 5x, plug it in for t, and then you have to, after doing that, you have to derive 5x and multiply by it. So the derivative of 5x is 5. And that is your answer if you simplify it, which you end up with 3 times 25x squared times 5, which is 5 times 25 times 3 is 375, I believe, x squared. The second fundamental theorem of calculus is extremely quick and easy if you can spot it, and it's going to save you a lot of time on a test where they ask you again to derive an integral. Again, when the interval has x's and the equation is a different type of variable. Now number 2 here is a little bit more difficult because it's not a constant to a x of some sort. So when they both have x's in it, you have to break this up into 2 separate equations. And what you do is it will basically look something like this. We're going to go from negative 2x to some constant. I'm going to call it a. You can call it whatever, just not x, and t. You don't do t either because t. And it'll be sine t dt plus my other one is going to go from that same variable. So from this to a, and then from a to the x squared of sine t dt. Now, if you want to use the letter C, it might be better because C stands for constant. For some people, it could be better. But I think the book uses A. So once you set up both of these, this one looks a lot like this. Because A is a constant, just like this is 2 is a constant. A is a constant. So this side is real simple. You simply are going to take the x squared, plug it in, and you get sine x squared. And then you have to derive x squared, and you get 2x. That's that piece. Now this piece, because it's backwards, the interval is backwards, okay? Remember with this, I always want the constant at the bottom. The second fundamental theorem of calculus, you want the constant and then that. So what you have to do, whenever you want this thing backwards, whenever you want to flip these two, you basically make your answer a negative. And then you're going to put the negative 2x here and the a here. So I flipped it. Now I can do this one using the second fundamental theorem of calculus. So this one's going to be the opposite of, when you plug in negative 2x, you get sine negative 2x. And then you're going to derive negative 2x, which is negative 2. And then this one, if you bring the 2x in front, you have 2x sine x squared. So it looks like my answer will finally be, when you multiply this negative 2 times this, it becomes a positive 2 sine negative 2x plus 2x sine x squared. That would be your answer. Again, don't forget the chain rule. Don't forget to set it up in 2 different sets. This is not as common as this. This is a more common one. This doesn't happen as much where you have to break it up in 2 pieces.